I see. So we will start the meeting about 5 to 5 minutes more.
Okay, Archit. Sure.
Sir, I think so we can now start the session.
Okay, guys. Yeah. Hi, all. A very good afternoon present for this session. And we will be having the last part of the boot camp today, wherein we'll be looking into what all things what we had learned in the past few days, few weeks on how data science concepts have evolved, what are topics we had covered, starting from the inferential statistics, descriptive statistics, building various machine learning models like the linear regression, logistic regression, classification models, tree-based models, and finally converging to the supervised and the unsupervised modeling techniques of clustering. So today I'll be giving an overview of how to do all of those things in the Python. In bits and pieces, I had shown you how to read the data, how to look into individual pieces of data, build the models like for sequence analysis, but how to do it in everything at one go, the way how we analyze the data, how we do the EDA upon the data and get an understanding out of it. Okay, so let me share my screen. Hopefully my screen is visible. Can you guys see my screen?
Yes, sir.
Okay, okay, yeah. So for today's session, where we'll be looking into the end-to-end life cycle of a data science project, starting from looking into the data, the sources of data, and picking up the data, doing an EDA on top of it, and gradually moving forward into the development phase and hyperparameter tuning and evaluation. Okay. So for that, I have picked up this popular dataset which is available on Kaggle, the Titanic dataset, which consists of the information about the people who were the part of the unfortunate incident which happened on Titanic in 1912, and it has got information about their information like the name, their age, their gender, the particular cabin where they were, and using all those criteria, can we build a model like which can say if a person belongs to this particular age and that particular chamber or that particular cabin he had booked or belongs to a particular gender, were there any other chances for him to survive, or like it was totally like no fair play was there, like anybody, there was no chance of surviving and it was totally a random game. Okay, so for that we will be looking into this particular data and try to analyze the data, see how the data is, and try to get an understanding out of it. Okay, so this particular data set is available on Kaggle. I think any one of you who is part of this session can go to this particular link and get an understanding of what is the Titanic data set. So this is a rolling kind of a competition which is going on, and unfortunately there are no prizes or awards for this. So anyone can go and register for this particular competition on Kaggle and get access to the particular data. And from that, the objective of the uh, particular competition is to build a classifier model, which would say any particular patient who was part of the particular uh, ship, the Titanic ship, was there any chance for him to survive or not to survive? Okay. So this is the description about the challenge. So it's saying about on April 15, 1912, the Titanic made its maiden voyage, and in that day, some 1,502 people out of the 2,224 people had died, which were part of the total passenger who were passengers plus crew who were there on the unfortunate ship. Okay, so from this total 2,224 number of passenger and the crew history, can we able to predict who is going to survive or who is going to not survive from the particular mishap which occurred. Okay, so for this, if I go into the data, so the data description, so any time you guys, you might be say the seasoned practitioner, or you might be a newbie into this particular data science exercise. So Anytime you look into any particular data set, just try to first get an understanding of what the data is. Okay, rather than directly jumping into the solving the particular use case, one should understand like how my data is, what are the different columns in my data, how does my data look like, what is the period for which my data is available, what is the point of origin for my data, if that is already split into training and testing, how many records are there, is it equally split, or what is the particular columns which have been dropped, and all those things. Okay, so in this, let me show you. So I have, like, someone else has already made this particular data set available on GitHub. So I'm directly pulling it up from GitHub. So in this particular link, I think it's some data science dojo. Under that there is dataset folder. From that there is titanic.csv. Okay, so using this particular file link, I will be reading into this particular file and building my all the analysis and all those hypothesis testing and building a model out of it. So from that I am linking it to this particular URL, the titanic.csv, the one which I had showed to you, this one. And from that I am reading, and this is how my data set is looking. Okay, so let us first see as how many rows are there. There are in total 891 rows. Okay, so there are total 891 passengers which are there, and out of the 891 passengers, we will be predicting as each of the patient whether that is going to survive or not survive. Okay, and there are 12 different columns there in the data set. Let's get a detailed understanding of what are the different columns and what does each of those mean. Okay, so for that I have to go back again into the data dictionary which is there. And from that I will see. So one is the survival. So the definition is survival as it is the basic English definition. So survival is either one or zero. So one is means the passenger has survived, and zero means it has not survived. And the P class, if you see there is P class, yes, there is P class. So the passenger class. So P class is the ticket class. So it can belong to any classes. It can belong to the first class, second class, or the third class, the particular class the passenger has booked. And that there is the name. So I think the name is the similar, the name of the particular passenger. It is not needed. And the other is the sex. So the sex is what is the identifier of the particular passenger, whether that is a male or a female. The third is the age. I think age should be the, okay, yeah. So sex is the normal sex identifier. Age is also an identifier. So what was the age of the particular passenger at that point of time? Okay. And SIBSP. So what does SIBSP means? SIBSP is number of siblings or spouses aboard aboard the Titanic. So how many siblings were there for that particular passenger while he was on board? And his spouses were also on board that Titanic. And the other is the P arch, which is the number of parents or number of children aboard the Titanic. So for a particular passenger, suppose if a passenger one whose name was Mr. Owen Harris, he was male and 22 years old. He had got one sibling on board Titanic while he had got no parents. Okay, he was unaccompanied by any parents and he had, I think, one sibling or any spouse. So SIBSP is either sibling or spouse, or PR is parents or children. Okay, PR, I think, parents or children, number of parents or number of children the particular person had along with them in the Titanic. The next is ticket. I think ticket belongs to the ticket number. So this is some random identifier for a particular patient, for sorry, for a particular passenger. So it can be alphanumeric. And I don't think like by using this particular feature, we'll be able to predict that a person is going to survive or not. Okay. The other is the fare. I think this is the fare, which, yeah, the fare is the passenger fare, the amount the particular passenger has paid. I think this might be some local currencies. Let's assume this is in euros. The particular passenger, how much fare he had paid for to avail the cruise services. The next is the cabin. Cabin is the cabin number. So this is like the which number the particular passenger belong to, which cabin the particular passenger belong to. So for many this thing passengers, what we will see is nan, right? So the information is not available for the particular passenger, like to which cabin they belong to. So based on the number of nulls, we will also see if those are useful or not, or it is wise to drop the particular feature. And the last is embarked. Embarked is the point of embarkation or the port of embarkation. Okay, so C means Cherbourg, Queenstown, or Southampton. That means from which port the particular passenger had got on board while in the fatal ship. Okay, so this is the
Why this
data. How it?
later? End again.
Hello. Okay, yeah, so this is how the data is looking like, and using this data, I will try to build a classifier model and try to find out if those passengers are going to survive or not. Okay, so prior to that, let's do some AD on my data as how my data is looking like. Are there any missing values or how, what are the statistics out of it? So using matplotlib, I am doing the df.describe. So for any of the continuous variable, this is the passenger ID. This is not required. So the count is 891. Okay, so this is not required. And I think, okay, so data is available for all except in the age. In the age, it has got maximum number of missing values. So 714 missing values are there in the column age. Yeah, so here, as you can see, right, there is a missing value. So similarly, there are many missing values like more than 100, 180 something missing values are there in the column age. And I think for this sibling and the parent, this has all the numbers filled. And these are the other statistics for the data like the mean, median, mode, mean, standard deviation, minimum is fine, 25th percentile for age is 20, okay, and 50th percentile is 28. That means on an average 28, the average age of the population was 28, and 75th percentile is 38, and maximum was 80. Okay, so a person of age 80 was also on board in that particular ship. So this is my range for age, and number of passenger classes is so maximum a person had got three accompanied either sorry, this one had got maximum three accompanied uh, parents or children, and the minimum was zero. Okay, and maximum and 25th and 50th percentile and 75th percentile also shows as zero. That means most of the people on board were like individual, they were not having any parents or children on board. And for the siblings and spouse also, like the maximum is 8. Maximum, like they had got 8 more siblings with them, and 75th is 1. Okay, so most of the people were still in the, like they were unaccompanied, like they were stag on board. And the maximum fare what they had paid was this much. So this is how we can get a detailed understanding of my data, as how much variance is there in my data and how much is my data homoscedastic or heteroscedastic. Based on this understanding, I can get a detailed understanding. Okay, so this is only for continuous variables. For categorical variables like the sex and the ticket and the cabin number, the point of embarkation, this won't be available. Okay, let's do a pairwise plot just to understand as how each of my features are correlated to each other with respect to survival of, like whether they are surviving or not, and the other continuous variables like the passenger class, age, fare, and all those things. What is the correlation among them? Okay, so this is what we have got. This is the pairwise plot. So as you can see, this is how the data is. So mostly it is quite scattered, where any point with the blue dot is 0, which means not survived, and orange means survived. Okay, So are there anything which is correlated to each other? I don't see anything because there is no linear kind of a graph between any of the features. Okay, a linear, by linear I means if passenger ID is increasing, the fare should also increase. If P class is increasing, the fare should also increase. But there is no such particular kind of a uh, pairwise plot indication in the data. And this is like what is the distribution for the particular this thing. So for passenger ID, so let's leave this thing. Passenger ID does not mean anything. P class, passenger class. Okay, so passenger class was what? It belongs to the three classes, one, two, and three. Okay. So for passenger classes one, two, and three, what is the survival versus the class in which they are in? So for a passenger who is there, so this is the three classes, one, two, and three. And for first class, as you can see, more number of patients have survived as compared to the people who had not survived. And for the third class, much more number of patients, sorry, the passengers they have not survived. They had succumbed to death as compared to the passengers who had survived. Okay, so this is the distribution, underlying distribution for the particular class they are in. And similarly, the age. So age, if I bin it into particular distributions, that means what is the particular, so my age can go from 25th percentile is 20, 28, 38, and 80. Okay. If I make it into four bins, 0 to 20, 20 to 28, 28 to 30, 30 to 38 to 80. If I make the four bins, 1, 2, 3, 4, four bins, I can see from here. So for which bin are the maximum number of people they have died, or for which the maximum people have survived. So if I would see, so less than, what was that? 0 to 20. So less than 20 maximum people have survived, and less, and a significant less have not survived. And the people in the middle age group, they have mostly succumbed to death, and 50% of them have survived as well. Okay, so this is the underlying distribution. This kind of an information I can get if I look into a pairwise plot. Okay, so fare also, like the people who have paid the least fare, they have also like they have died as compared to the one who had paid the highest fare. Okay, so this fare, and I think the uh, fare and what let's see, fare and the passenger class, are they correlated? Yes, they are correlated. We can see that the passenger class one, most of the people they have survived as compared to the, I think it's an overlap plot, so it's not clearly distinct. But if we do a any stacked plot, it will clearly show a distinct underlying distribution for each of the classes and the particular features which are there underneath. The next kind of an EDA, what I can do is the correlation matrix. So this is the correlation plot what you had seen. This is a visual representation. In place of a visual representation, if I want to try to do that as a any quantification measure, that means if those are positively correlated or negatively correlated, or they are not correlated as with each other. Okay, for each of the continuous variables, I will try to find the coefficient, correlation matrix, correlation coefficient. And from that, let me see, is there any positive correlation with anyone? Okay, so this is 0.41. So number of siblings and the this number of parents or the children's what they are accompanying, this is the highest. Okay, that means anyone who is getting on board with the number of siblings of say two would also be having the number of parents or children to be two. So this is like positive correlation which is shown. And is there any negative correlation? So yes, negative correlation is shown in the passenger class and the fare. Okay, so if fare goes up, the passenger class goes down. This is like what the data shows to me. And yeah, so this is the same for this. And what all? Is there any information? No. Okay, so this is the information that I'm getting from the correlation matrix. And let's see the count plot for the categorical variables. So the number of out of the 800 and some passengers, so a total I think 600 something they had not survived and 300 something had survived. Okay, out of the total data, this is what my bar plot shows. And if I do a similar bar plot to the classes where they were, right? The one which you were seeing over here, where is the P class? Yeah, so one which you were seeing over here. So this was comparative to each other. So this is with the survival rate. So for the first class, second class, and the third class. So in the third class, maximum people have died as compared to the people who had survived. And is sex going to play a major role in the people who are going to survive or not? So yes, so more male have died. The males who have died to survive, the ratio is much more higher in the case of the male as compared to the female. So in female it is opposite, but in male it is like many more people have died as compared to the people who had survived. And let's do some hypothesis testing on the basis of the uh, continuous variables that I have. That means, is age a crucial factor for me for a person who is surviving or not surviving? Okay. So for that, what I will do is I have divided it into two groups. One is the age of the people who have survived and age of the people who have not survived. And my hypothesis is that the average age of the people who have survived is equal to the average age of the people who have not survived. That is my basic hypothesis testing that I'm trying to do. And that is my null hypothesis. And my assumption is that null hypothesis is the average age of the people who have survived and the average age of the people who had not survived, their age are equal. Okay, that is my null hypothesis. And based on that, I have done a t-test because I had got uh, it was following a t-distribution. And from that, I tried to find out. And from the test, what I got to know was this was the t-test score and the p-value was 0.03. Okay, so as you had known, right, if you can recall from the inferential statistics what we had done for the hypothesis testing, my confidence interval or the significance level is 0.05. Anything which is coming as 0.05, if the p-value comes as 0.05, then we can directly reject the null hypothesis, stating that my null hypothesis is not true. Okay, so we can say that the age of the people who had survived and age of the people who had not survived, it is not equal. Okay, so that is my test what I have done, and that is my conclusion. And similarly for the fare, so for the fare which the people who have survived, whatever they have paid and whatever who have not survived and whatever they have paid, so like based on this, like can we say that was there any parity or any bias in the way they were rescued, right? People who have paid much more amount were they rescued, or people who have paid less amount they were not rescued? So what I will do is the average fare which the people who have survived their fare and the average fare which the people who have not survived, I will do a hypothesis testing. Similar, I have done a t-test and it is still coming as less than 0.05, way less than 0.05. So I can straight away reject the null hypothesis, stating that their average is not equal. That means the average fare which the people have paid who had survived is not equal to the average fare with the people who had not survived. Okay, so my hypothesis is invalid, and there is no particular evidence which suggests that there was any disparity in which the people had survived. Okay, similar t-test I can also do for any other hypothesis test. I can also do for any other kind of a variable that can be, say, the age, right? Age is already there. I can also do for the male to female. Are the male the people who were male, are they going to survive, or the female, are they going to survive? So based on that, because that is a, what is that, that is a categorical variable, so a t-test would not be valid over there. So then I need to go to do any other categorical test like the chi-square test. Okay, so those are tests you can do on your data and frame up your hypothesis, and then on the basis of that you can pick up any of the variables or pick up any of the hypothesis and state that yes, this is what is my underlying data telling, and that you can pass it on to your, say, the investigating agencies or your business stakeholders. And from the data what we had got which columns? We had got these all columns, right? So from this, what we understood is we cannot use like the columns such as the passenger ID, because passenger ID is something which is random, right? It won't give any information about the particular passenger. And similarly, the name is a numeric alpha, this thing. So we just can't use this. It doesn't mean anything. Anyone's name can be anything, and it has got no impact on if the person is going to survive or not. Similarly, the ticket number is also an identifier, alphanumeric, and the cabin, because the cabin has also got a many number of missing values. I thought like it's better to drop that. Otherwise, we can also still use the cabin as an identifier just to say if a particular uh, passenger belonging to any cabin was there any chances of surviving or not. Okay. So from that, what I have done is I have dropped all these features from the data, and I had created my new data frame. Okay, so this is my new data frame, what I have over here. So this is how my new data is looking like. I don't have those unnecessary data feature columns which are there, which were acting as identifier for me. I can straight up remove those and build up this build up my model using this particularly available set of features. Okay. Let's see for missing values. Okay, from the df.describe, if you remember, we had done the missing value check also, and using the df.isNA.sum, I can check for how many missing values are there in each of the particular features which are there. So none of the missing values are there in any of this. Only in embarked there are two, and in age there are 177 missing values. Okay. There are 177 missing values in the age thing, and there are only two in the embarked thing. So what I will do is I will try to impute the missing values. So there are many different techniques which are there for missing value imputation. I think we have discussed this in this extensively also. For continuous variable, for categorical variable, is a continuous variable. What I will do is I will fill that with the median age. Okay. So what was the median age in the df.describe? If you remember, the median age was 28. Okay, so for anyone, for the data which is missing, because we know that out of the 890 who were there on board, more than 50% of the people are of the 28 age group. Okay, so my assumption is that I can directly impute them with the 28 as their average, as their median age. I fill that with the median, and as embarked is a categorical feature, right? Embarked was a categorical feature, the point of embarkation. So for that, what I have done is I am filling that with the mode. Mode is the most common occurring data point for a categorical variable. Okay, that is how I have filled those missing values. And let's check for the data types. Okay, for each of the features which are there. So this, I think this is binary, right? So this is a integer data type, and others are such is a categorical data or object type of data. So this is also an object type of data. So I need to check for what are the different type of data types, and if those are object kind of a thing, my model might not be able to learn those underlying insights. I have to convert this object data type or categorical data type into numerical data type for my model to understand, or my computer or my computing system to understand. So for that, I will do first I will check for the data types, and from that I found out like sex is the object type and embarked is the object type. Then I will convert my categorical data to numerical data. Okay. One way of converting that is directly mapping. So for male, I have made it 0, and for female, I have made it 1. Okay, this is one way. And the other is the one hot encoding, wherein if there is a male, I'm creating one particular column, and for female I'm creating another particular column, and those who are male will get the value 1, and those who are female will get the value 1, and vice versa, I would get the value 0. So pandas.getDummies, I am creating the one hot encoding for this. So anything can be done. So don't worry about like I followed one hot encoding, so one hot encoding would be the best. You can do any other thing. You can also do the label encoding as well. So for simplicity, I have taken up these things and sorry, let me, I have to rerun it again. Okay. So where were we? Okay. So for this, I have converted them to categorical variable. So for sex, it becomes 0 and 1. And for this embarkation point, it had made into two different columns. Okay. One is embarkation underscore Q, embarked underscore S. For a person who has embarked from S, it would be 1 and the other would be 0. That is how you do the one hot encoding for your model to understand all of the numerical features. So what you had seen is I am doing this every time step by step. I have to write it and note it down that which are the numerical features, which are the categorical features. And first I need to do the missing value imputation and then I have to do the this transformation like this one hot encoding kind of a transformation, or if there is a numerical feature for them to make it normalized or make it scale to one particular scale, I have to do the scaling on top of it. So if you would see, there is a particular step I am following every time. That means first I have to check for missing values first, and then I have to do the scaling. Okay. Without doing the missing value imputation, I can't do the scaling because there would be null values within under that. And similarly for categorical features, I have to do the missing values imputation, and then I have to do uh, the one hot encoding or the categorical to numerical feature kind of a transformation. Let's write it as transformation. If I do it other way around, it might not be useful for me. Because this is in a notebook format, I know like what steps to follow, what after others, and it can go in that particular fashion. But if you are doing that in a large scale, you might not be sure like what to do after other, and there are different parts of the code which are running in different bits and pieces. So to standardize all of those things, what has been done as a standard practice is creation of pipelines. Okay. So let's see how pipelines are constructed. So under sklearn, the same scikit-learn which you had been using for all those model building stuff and all those transformation stuffs, it has got the feature called as pipeline. Okay, under sklearn, there is a feature called as pipeline, and under pipeline, you can create your own pipeline for different type of data. Because I know like for continuous variable, I have to do first missing value and then scaling. I can create a pipeline for this, which will do this first and do this second. And similarly for categorical variables, do this first and do this second. So this is how I have done. So I know that my numerical features are age and the fair. Okay. And from that, the using the pipeline feature of scikit-learn, I am first. So this is the steps. Keep this in mind that this follows a sequential kind of a pattern. That means first what you have written is done first, and then second what you have done written is done second. So for this, the first what we are trying to do is a missing value imputation. So for imputation, I can do the any other thing like the fill NA or any other thing. So for that, basically, I'm doing a simple imputer and strategy is median. I'm filling that with the median value. The other is the scalar. I'm doing a standard scaling on top of it. Okay. And for categorical features, I know my categorical features are the sex, P class, sibling, P arc, all those things. These are the categorical features. For this, I'm doing the categorical transformation. And the first I'm doing the imputation, the other is the one hot encoding. Although you can argue that these all features are numeric in nature, right? While we were looking to the data, the siblings and the parent or the children, those are numeric in nature. But if you carefully see over here, they are quite distinct. That means a person can be accompanied by either zero partners or one partner or two or three partner. So it is in itself a categorical number. That means the number would be a distinct number and we know the maximum and the minimum of it. So the maximum was 8 and the minimum was 0. So through that way, we are trying to do a some kind of a our model to learn not that as a continuous variable, but as a categorical variable. So based on that, this is a categorical transformer, and these are the pipelines. So first is the imputation, the second is the one-hot encoding. So for all of this, I'm trying to do a one-hot encoding. Okay. Uh, you might see that I have already done this. So this would override the, if I do this pipeline thing, this would override these all techniques. And this would be still be there as separate features, but it will override this and create other features on top of it. So let's run this. And I am combining the pre-processing steps into one using the column transformer. Okay, because each of this is needs to be done on the features what I have. So I am clubbing all of those into column transformers. And under transformers, it also has two different, like you can create your own number of the based on the number of pipelines that you have. You can create your own different identifier. So one is the num, the other is the cat. This is for numeric transformer, what we had already built over here. So this would call this, and it would take the numeric features for this. So the numeric features are the age and the fair, and categorical features are the this all things. Okay, so this is how it we are integrating the pipeline into one particular object, which is coming under the preprocessor object. And let's build the model what we have based on all of the data what we have. Let's try to build the model. So from the data, uh, okay. If you look into the data, my data was like this. Okay. So my target variable was what? The survived. If the particular passenger is going to survive or not. So based on the other independent variables, that is from the P class to the embark test, using all these features, I'm trying to predict for this particular values if it is if the particular passenger is going to survive or not. So I am picking up the survived column and creating that as Y and the other independent features as my X. Okay. I'm picking up a random forest classifier, and for hyperparameter tuning, I'm picking up the grid search CV, and for splitting up my data, I'm doing the trend test split. So X is the all the features except the survived, and in Y I have the survived. Okay. Let's see how my X and Y are looking. This is how my X is looking, and this is how my Y is looking. Okay. I hope this is clear till now. And these are the numeric features what I had. So already I had defined it earlier also. I am still writing it for my understanding. So, okay. So sorry, this is based on the different thing. This also includes, this is only on the basis of the categorical data type I am picking, but I have to drop it because already I have done the same thing and I have the P arch and the sibling, all those things as categorical features. Okay. And using the trend test split, let's split my data. So I'm splitting it into 80-20. So 0.2 means the test size was a 20% and 80% of data is in my, mm, let's make it Stratify. Okay. Stratify is Y. So in 20% of my data is in my test and 80% of my data is in train. Okay. So in X train, Y train, 80% of my data would be there, and X test, Y test, 20% of my data would be there. So if you remember, there were different kind of sampling techniques which were available. One is the random sampling, the other is the batch-wise sampling, and there is something called as a stratify sampling. In stratify sampling, what we do is for the patients who had survived to not survived, what was the underlying distribution in the original data. Suppose say in our original data, what was the particular this thing df dot df of survived dot value. Let's first find the value counts. Okay, so here if you'd see 549 passengers had survived and 342 have not survived, right? So what would that mean? So 549 by 549 plus 342. So 61% of the passenger had survived and the rest 38% they had not survived. Okay, so the ratio is what? 61 is to 38. This is how my data is there. This is how my data is there. Okay, so 61% of the people have survived and 38% of the people have not survived. This is how the distribution is there in my underlying data. I want the same distribution to be there in my training and testing as well. So in the 80% of the data what I'm picking up, so from the total, how many data was there? 849, right? Out of that, 0.8 679 data what I am picking up, in that total passengers, the same 61 to 38, the ratio should also get followed. That is what I want. Okay, for my model to have that equal understanding of how my data is. And similarly, in the rest test data also, the same number of feature distribution should be there. That is what I want for my model to learn from, so that there should not be any bias for, suppose say while training and train and test split, suppose in my data, in the train data, 90% of the people have survived and 10% of the people have not survived, right? So my model would anyway be biased for 90% of the people. It would not learn the characteristics of the 10% of the people. So to have a uniform or a detailed understanding of the people who are there in the both of the split, I have to do it stratifically. So that is why I have done it stratify is equal to y. Okay? Based on y, the distribution which is there, based on that, it will do the split. Let's split the data, and this was the pipeline which I had already built earlier, and the preprocessor object, if you remember, which we already had, and we are for a classifier, we are. So you can also look into the particular these things also, like what are the uh, variables which go, what are the parameters, and what are the different hyperparameters which are there for any of the particular object. So based on that also, you don't need to remember anything. Just you need to remember that if you want to build a pipeline, so pipeline is available on sklearn, and sklearn, under that you can go to steps, and the steps, these are the different things what you need to explicitly mention about. And this is the random forest classifier which I had uh, which we had used, and this is the hyperparameter tuning what we are doing on top of the data. Okay, so for the random forest classifier, there are different hyperparameters which are available. These are the different parameters which are there for my uh, hyperparameters which are there for my random forest classifier. Okay, so the if you remember, like there were different hyperparameters which would say like how if the data would get overfit or underfit, right? So these are the number of estimators, these are the this is the criteria, the Gini index or the entropy, and this is the maximum depth, as how much deep the tree can go under, and this is the number of sample split, this is the number of sample sleeve. So all these are hyperparameters, and based on the your understanding and based on the data's understanding, you can define like what should be the optimal value for each of the particular hyperparameters. Okay, so these are the different hyperparameters which are available for the random forest classifier. And based on my understanding, I said that for the number of estimators would be, or the number of estimators is the number of, because the random forest is the number of trees what it is building, right? Number of decision trees what it is building. So I have said that it can be 50 or 100 or 200. So based on this, you can pick up anything. And the maximum depth, so it can be 10, 20, 30. Number of sample split is 2, 5, 10. So for simplicity, I have taken this three hyperparameters, and based on that, I will be building this particular random forest. And I am doing the grid search CV. So this is the model which had already done. This is the parameter grid. This is the cross validation. That means how much iteration I will do on top of my data, and based on that I will try to find out like what is the best model which I have got. Okay, so I think we have not covered on cross validation. Just remember this, under training data we are in itself splitting the data into individual parts, and based on those unseen data we are trying to predict on those particular parameters. Okay, and the scoring, we have only focused upon accuracy, though it can also be precision, recall, or the F1 score, or the any other classification matrices. And based on that, I am doing the grid search dot fit, and from this, I'm trying to estimate the best parameters and the best score for my model. Okay, so it might take some time for my model to run. It is taking some time. Let's wait. Okay. So this is the best parameter what we have got from the grid search CV. Okay. So from all of this, my model, after doing a random substitution for each of the hyperparameters, it had found that the maximum depth, the best is 10, sample split is 10, number of estimators is 100. Okay. So by taking all these hyperparameters, when I fit it into my random forest classifier, my accuracy is coming to be 0.82. Okay, 82% accurate my model is, which is in pretty much a decent score for me for my model. And to have a visual perspective of how good is my model, I can also plot that in a ROC AUC curve and also into a confusion matrix. Okay, let's have the confusion matrix. So this is the confusion matrix. So 0 and 1, this means either survived or not survived. And this is the values. So precision is coming as 0.81, 81% precise is my model. That means the 81% it is predicting the positive things out of all the things which is predicting as positive. And 89% is recall is there, which is a significant good score. But if you'd see for the people who had not survived, the recall is quite less, that is 0.67. And the aggregated F score, if you would see, the accuracy is 0.80. This is on the test data. So we are looking the confusion metrics on the test data. So if you see, the accuracy is coming as 0.80 or 80% accurate. Okay. And our weighted precision is 0.80, weighted recall is 0.80. So weighted, if you would see, like we had got the imbalance within the data, that means it was not balanced, right? 61 to 38, what the distribution was. If I can put that as a weighted kind of a thing, with 61 as a making that to 50 as 50, making to 50-50. So my recall would come as 0.80, and F score is also coming as 80%. So which is a pretty decent score for a classification metric. And if I plot my ROC AUC curve, okay, let's plot my ROC AUC curve. This is how my ROC AUC curve would look like. On the left, you'd see the true positive rate, and the x-axis is the false positive rate. So my thing was, if my ROC AUC curve, the value is coming as positive and it is coming towards this thing, more towards the true positive rate, then it is best. Okay, that means the ratio of the true positive rate to the false positive rate is high. So it is pretty much coming as in this direction only, and the AUC area under the curve is 0.82. Okay, which can be 1. The highest would be 1, but it is coming as 0.82, which is still good. So this is how like we can quantify and see into the our model and get an understanding of how much accurate or how much precise is my particular model. Okay. So the same thing I can do with a baseline model, like say logistic regression. I did the same thing, and without doing any hyperparameter tuning, I have want to try the same thing. Okay. So for hyperparameter, without doing any hyperparameter tuning for logistic regression, as you can see, the results are also coming like much better. So it is coming as 0.88, which is much more better as compared to a random forest. Okay. So that is how, like, by using different kind of an architectures, you can play around and get an understanding of how good or how bad your particular model is, and get a detailed understanding of your particular uh, underlying data and underlying feature transformation what you have done, and on the modeling techniques which you have followed. Okay. And is there anything else? No. Okay, any questions till now? Any questions till now? So there are other aspects of this as well, like what I can do. So with the best model that I have got till now, what I can do is I can save those particular model back into my system as this is my best model, and using those model I can serve it on the go as well. If I have got any other web architecture, like any deployment technique like Flask or AWS or any other uh, architecture, under that I can make it as an API and available it on the web, and based on that I can do the inferencing on the go. Suppose if there is any other customer facing application which I want to build, I can pick up my best model, use that model in my particular uh, execution engine, and using the inference architecture I can fetch the data, all those customer data which is available, and based on the customer data I can henceforth predict what would be the output for a particular customer. Okay. That is how, like, a total end-to-end thing is done. So today we covered, I think, everything starting from uh, uh, just looking into the individual data to building a model out of it and just predicting like which of the particular passenger would be surviving or not at the end of the day. Okay. So yeah, that's it for today and for the course as well. So this is what we had till now, and I hope we had covered everything. Though there were many things which were part of the uh, total whole curriculum of the AI, machine learning, deep learning, and all those things. But given the time frame and that given the scope of the coursework what we had covered most of the things, and hopefully I'm expecting you all guys to be much more would have gained a lot out of all of these things and would be eager to implement these things in your near future. Okay. And this is my feedback link. I'm expecting you guys to provide a feedback. I will pass on this to this link to Arish as well. He can put that in the uh, Discord server for the people who have not attended the sessions and who had attended the previous sessions also. They can give their own feedback. So if you guys are having your this mobile handy, you can scan this QR code and give me a feedback for this particular course. This would really be helpful for me and to get an insight on what you guys have learned, what went well, and what all things could had been made better. Okay. Hopefully expecting a positive response from your side for this particular feedback. Okay, Ayush. Hello.
Yes, yes, thank you, sir, for this great session. So if anyone has any doubt, so they can ask. Otherwise, we can we can end this session, I think so. If anyone has any doubt, they can raise their hand right now. So I think so we can now wind up. I think it was a very great session, and we learned very many new things from this session. Thanks a lot.
Thank you, Archit, for your word, and hopefully, like other people would have also learned on the go as well. And definitely, I was also like quite excited to take this session, and definitely it was quite enriching for me as well to go back to the concepts and learn and make it uh, in the handy format so that the students or the practitioners who are from the different age groups, they can also learn and upskill themselves. So thank you all. Thank you. It was definitely a great experience for me. Thank you. Hopefully we can meet soon.
Yes, sir, surely. Thank you.
Thank you. Bye.